Hello and welcome back to the Operations Research 2 course. We're going to finish the topic about probabilistic dynamic programming with two examples. So let's start. In this example, a department store is trying to determine an optimal cash management policy. The difficulty here is that the demand for cash is a random variable. It means that you cannot know for sure how much the demand for the cash today in your department store. Okay, so it's a random variable, and the probability that the value is exactly d or small d is pd. Okay, so big D is a set of a lot of possible values, and then the probability that a specific value of d happens is pd. In this case, at the beginning of each day, the store sends an employee to the bank to either deposit or to withdraw funds. And each time there's a transaction with the bank, either you deposit money or withdraw money from the bank, there is a transaction cost of K dollars. So for each day, the department store may satisfy the demand for the cash by the cash left from the previous day. So you can think of it like an inventory. So the cash you have from the previous day plus the money withdrawn or minus the money deposited to the bank. So it's similar to inventory, like the cash that you have from the previous day plus if you withdraw money or minus if you deposit some of that cash that you have from the previous day to the bank. And the remaining is the one that you use today to do the business in your department store. Okay. Now at the end of the day, the store determines its cash balance. If the cash balance is negative, means that your business actually needs more cash than you provide at the beginning of the day, then there's a shortage cost of S dollars. However, if it's the other way, the ending balance is positive, which means that the money that you provide at the beginning of the day exceeds the amount of money that is needed for business that day, then you get a cost of I dollars. So you can think of this similar to the holding cost, like you have an excess of inventory at the end of the day. So it's similar to that. At the beginning of the day one, the store has $10,000 cash on hand and a bank balance of 100,000. Formulate dynamic programming that can be used to minimize the expected cost of filling the store's cash needs for the next 30 days. There will be a pause on the video to give you the time to read this problem carefully before you continue. Let us define the stage, state, and decision for this problem. The stage is kind of obvious. It's the day T. We have stage 1 up to stage 30. And the decision is also quite straightforward. We just need to decide at the beginning of each day how much money we withdraw from the bank or we deposit in the bank. And it is denoted by X. The convention here is that if X is positive, it means that you withdraw money from the bank because you get more money, so X is positive. X is negative means that you deposit the money because now your money becomes less, so X is negative. Okay, but actually you may make your own convention as long as you are always consistent with it throughout the formulation of the recursion. Okay, so here it is just the convention. X positive means you withdraw from the bank, so you have more money. X negative means that you deposit money, so now you have less money on your hand. Okay, So remember that state is the required information such that you can make a reasonable decision. So for example, if you want to decide the amount of money that you withdraw from the bank, of course you need to know how much you have in the bank, right? You cannot decide, let's say you want to withdraw money $10,000 from the bank, but actually in the account you don't have that much, right? So state is the information that you need such that the decision that you make or the possible decisions that you consider are reasonable. Similarly, when you want to decide how much you deposit in the bank, you need to know how much cash you have on hand, or in this case, how much cash we have at the store at the beginning of the day. Let's say you only have the cash of $500. Of course, you can at most deposit $500. You cannot deposit like $1,000 because the money that you have on your hand is only 500. So that's how you know what the states are. Once again, states are the information, the condition, the situation that you need to know such that you may have reasonable decision to take. Okay, so these are our stage, state, and decision. So here's the formulation at the very last stage on the day 30. So we have F30 and we have two states here. The cash we have on hand at the beginning of the day and the cash that we have in the bank. So F30CB means the minimum expected cost. So F is cost incurred by the store during day 30. So this explains this 30. Given that at the beginning of day 30, the store has C dollars cash at the store and B dollars in the bank. So this is the complete definition of F30CB. Do not forget once again that F is cost. So the unit for F, whether it is F30 or later F29, 28, 27, and so on, it's about cost. So the unit is, let's say, dollars. Okay, because this is cost, so we just list all the possible costs that may happen here. The first one is transaction cost. We read in the example that the transaction cost happens whenever we either withdraw money from the bank or deposit money from the bank, and the cost is big K. So how to formulate this? Well, we multiply K with a function called delta X, in which if X equals 0, the value of delta 0 is 0. And if X does not equal to 0, whether it is positive, means we withdraw money, or negative, which means that we deposit money, dx, the value of dx equals 1. So K times dx is the transaction cost. And the value of dx is governed by this function. Okay, so d0 equals 0, dx equals 1. So this is the first time we're seeing this kind of function. Again, it has the usage to show whether we do the transaction or not. If we do the transaction, then we have the cost of K. If we do not do any transaction, then the whole thing is 0 because K times 0 equals 0. Now the aspect 1 says that we can only withdraw the money. We can withdraw the money less than what we have in the bank, right? So that's why X is less than or equal to B. B is the money that we have in the bank, and X is what we withdraw, must be less than or equals to B. The money that we deposit in the bank, because the sign is negative, now X must be greater than or equals to minus C, which means that if you have the cash, let's say $59 on your hand, then X can be minus 59, minus 58, minus 57, minus 56, and so on. So those numbers means that X must be greater than or equal to minus 59. Okay, think about this carefully. For negative numbers, if you want to say minus 59, minus 58, minus 57, minus 56, it means that those numbers are greater than or equal to minus 59. Finally, combining these two requirements together, this is our aspect 1. X must be greater than or equals to minus C, must be less than or equals to B. In the previous slide, we have formulated the transaction cost. So now let us talk about another type of cost, which is the holding cost. Holding cost occurs when you have remaining money in your store at the end of the day. For each dollar that you have in the store at the end of the day, there is a cost of I dollars. So at the end of the day, we will have money remaining in our hand as much as C plus X minus D, because C is the money that we have at the beginning of the day. X is the amount of money that either you withdraw from the bank or you decide to deposit at the bank. And then minus the demand for the money to do the business at this day T. Okay, so the remaining cash or the excess of cash that we have at the end of the day would be C plus X minus D. Remember that X may be positive if you decide to withdraw money. X may be negative if you deposit some money to the bank. Now, as usual, when we say if the demand equals D, it means that you must multiply this thing with the probability that the demand D is happening, which is PD. Now, one important thing is that we will take the sum of this over all possible values of D, in which D is less than or equals to C plus X. This means that we are going to take the sum for all values of D in which the demand is less than the cash we prepare for the day. And that is why we have an excess, right? You prepare much more than the demand, or in other words, the demand is less than what you prepare. That is why you have excess amount of money, and then you experience holding costs. One more time, because the demand is less than what you prepare. On the other extreme, the shortage cost happens when the demand exceeds what you prepare. So let's say you only prepare $100 in your store at the beginning of the day after you do the transaction with the bank, but then suddenly the demand for cash today is $250. So there is a shortage. You prepare 100, the demand is 250. If that happens, then you experience a shortage cost S for each dollar of shortage. And how much shortage you experience? It is D minus C minus X. Because if the demand is D, the shortage would be the demand minus what you prepare. And what you prepare is the cash that you have at the beginning of the day, C, plus how much you do the transaction with the bank. Either you withdraw from the bank or you deposit to the bank. So D minus in the bracket C plus X, or if you expand the bracket, it becomes D minus C minus X. So this is the amount of shortage that you experience at a particular day. Same as before, you need to multiply that with the probability that the demand is actually D. And then we take the sum over all possible values of D in which D is greater than or equal to C plus X, which means the demand is more than the cash that we prepare for the day. And that's why we have a shortage, right? The demand is bigger than you prepare, so there is a shortage of cash. And that's why you experience shortage cost. Now let us go backward to the stage before the day 30. That's why the T is small. So FTCB means the minimum expected cost incurred by the store during day T, T plus 1 up to big T. Given that at the beginning of the day we have C dollars, cash, and B dollars in the bank. Everything is quite similar like before. We have transaction cost, and dx is this function here. We have a holding cost, we have a shortage cost, and this is the aspect 1 to put the restrictions on x. So up to here, everything is the same with the stage 30. In the next slide, we're going to talk about the aspect 3 here. So in aspect 3, we need to write down how our cash position changes from stage T to stage T plus 1, and how is our money in the bank changes from the period T to period T plus 1. So the cash that we have on hand will change from C to become C plus X minus D at the beginning of the next period. So C is the money that we have at the beginning of stage T. X is the money that we either withdraw from the bank or deposit to the bank, minus the demand of cash that happens during this day when we do our business. So our cash position next day is C plus X minus D. And if you think about it, it is assumed here that the cash position may be negative. And then for the amount of money in your bank, it will be B minus X. So B is your initial amount of money in the bank, minus X is if you withdraw the money, the value of X itself is positive. So B minus X, the money that you have in the bank will be reduced. If you deposit money, then the value of X itself is negative. So B minus negative X becomes B plus X, which means that the amount of money in the bank that you have will be increased on the next day. Okay, so this is FT plus 1, but again, this is something that depends upon the demand. So if the demand is D, then you will have these states. As usual, if you have something like this, if the demand equals D, you need to multiply it with the probability that D is happening. In this case, it is PD. And then, as always, again, we need to take the sum over all possible values of D. So that is how we complete this part, which is also called the aspect 3 of the formulation. So the special thing about this example is that for the very first time we see this kind of function in which we define if the value of x is 0, then delta x equals 0. If the value of x is anything else but not 0, then the value of delta x equals 1. And that is how we formulate the transaction cost. Okay, so that's all for this example. See you on the next one. Thank you.